80 feet. Not a movie. Not a guess. That is the largest size science can still defend for this animal. 15 million years ago, in warm water that covers half the planet, a whale is swimming alone. It is not a small animal. 9 meters of muscle and blubber. In this ocean, it has almost nothing left to fear. Below it, at the edge of the light, something changes direction. It does not look the way you expect. It is not a wall of muscle. It is long. It is narrow. It moves the way a submarine moves, without spending anything to do it, and it has been holding this exact distance for hours. The whale never sees it turn upward. 276 teeth close on the base of the tail, and the largest predatory shark that ever lived takes away the one thing the whale needs to escape. Here is the problem with what you just watched. The animal in your head right now, the one you have seen in every documentary, every poster, every model, and every gift shop, almost certainly never existed. For 100 years, we drew Otodus megalodon as a great white shark, scaled up until it filled the frame. In March of 2025, 29 researchers across 9 countries published the reassessment that ends that picture. We had it wrong. Not the length, the shape. Start with what is actually missing. There is no megalodon skeleton. Not a partial one in a drawer somewhere. Not a crushed one waiting to be prepared. There is no complete megalodon anywhere on Earth, and there never will be. Sharks are not built out of bone. Their skeletons are cartilage, the same material in the tip of your nose, and cartilage does not survive in rock. When a shark dies, the body opens, the cartilage dissolves, and within a few decades, the animal is gone. What is left is teeth. Megalodon teeth are everywhere because megalodons shed them constantly, the way every shark does. Thousands of teeth across a single lifetime, falling to the seafloor and getting buried. The largest of them run about 18 centimeters, from tip to root. You can hold one in 2 hands. People find them on beaches in South Carolina, on ordinary Tuesdays. And for most of the last century, that tooth was the entire measuring instrument. The method was simple, and that was the problem with it. Take a great white shark, measure its largest tooth, measure its total length, get a ratio. Then take a megalodon tooth, apply the same ratio, and read off a number. That number came out somewhere between 15 and 18 meters, 50 to 60 feet. It appeared in textbooks. It appeared in museums. It is where the great white comparison came from in the first place. Not because anyone had evidence megalodon looked like a great white, but because the great white was the ruler. And after a while, people stopped noticing the difference between the ruler and the thing being measured. Because here is what that method quietly assumed: that megalodon and the great white are built the same way. They are not related closely enough for that to be safe. The great white belongs to a family called Lamnidae. Megalodon belongs to Otodontidae, a separate lineage that split off long before, ran its own experiment in size for 20 million years, and then ended. Using one to measure the other is like estimating a rhinoceros from a horse. Same general outline, completely different animal underneath. So the 2025 team threw the ruler away and started somewhere else. They started with vertebrae. Shark vertebrae are the one part of the skeleton that sometimes mineralizes enough to fossilize. Dense little discs, stacked like coins, down the length of the animal. Megalodon vertebrae are rare. Complete runs of them are almost unheard of. But one exists. A partial vertebral column recovered in Belgium. Not a full animal, but enough of a spine to work with. The team took that column and then did something the old method never did. They measured body proportions across 165 species of shark, living and extinct, not to find a single stand-in for Megalodon, to find out how sharks are proportioned in general. How much of a shark's total length is head? How much is trunk? How much is tail? The answer came back consistent enough to use. Head, roughly 16.5% of total length. Tail, roughly 32.5%. Apply that to the Belgian column, and the animal it came from was about 16.4 meters, 54 feet, which is a large shark and not a headline. The headline is in Denmark. Because there are other Megalodon vertebrae in collections, and some of them are bigger. One from Denmark measures 23 centimeters across. A single disc of a spine, roughly the width of a dinner plate. Run the same proportions on that one, and the animal it belonged to reaches 24.3 meters, 80 feet. Now hold on to one thing about that number, because almost everyone who repeats it gets it wrong. 80 feet is not what a megalodon was. 80 feet is the ceiling, the largest size the fossil record can still justify, without inventing anything. It is the outer edge of the possible, not the middle of the ordinary. Most megalodons that ever lived were considerably smaller, the same way most great whites are nowhere near the record. But the ceiling matters because of where it landed. In 2018, a summer blockbuster put Megalodon on screen at 75 feet, and paleontologists said out loud that Hollywood had gone too far. 7 years later, the science came in higher. But the number was never the strangest thing in that paper. Because while the team was measuring how long the animal was, they were also, unavoidably, measuring how it was built. And that is where the last 100 years of reconstruction fell apart. Go back to those proportions. 16.5% head, 32.5% tail. Put those against a great white, and they do not fit. A great white is stockier than that. Thicker through the middle, shorter in the tail, built like a torpedo with the weight forward. Megalodon's proportions point somewhere else entirely. They point at the lemon shark. The lemon shark is a slender, elongated, unremarkable-looking animal that most people have never thought about for a second. It is not a monster. It is a shape. And it is the shape the vertebrae keep pointing to. Which means the real megalodon was longer than we thought, and thinner than we thought at the same time. Not a great white blown up to fill a movie poster. Something closer to a gigantic, streamlined cruiser, narrow through the body, long in the tail, built to move, rather than built to look dangerous. And once you see that, the second finding arrives on its own. Because the slenderness is not a detail. The slenderness is the reason the animal could get that big. Look at what else the ocean has managed to make enormous. The whale shark, the basking shark, every large whale that has ever existed. Not one of them is stocky. Every single one is long and narrow. That is not a coincidence, and it is not aesthetics. It is physics. Water is roughly 800 times denser than air. Pushing a body through it costs energy, and the cost does not scale politely. Weed in an animal, and the drag climbs faster than the size does. A stocky body at 10 meters is expensive. A stocky body at 24 meters is a body that cannot afford to feed itself. So the ocean has a rule, and the rule is simple. If you want to be gigantic, you have to be thin, stay narrow, and the door stays open. Get thick, and the door closes long before you reach the record. Megalodon went through that door, further than any predatory fish before or since. And that changes what the animal actually was. The great white version of Megalodon is an ambush animal, a wall of muscle that hides underneath something and detonates upward. That is how great whites hunt, and for a century, we assumed Megalodon simply did it at 4 times the scale. The slender version does not hunt like that. A long, narrow, hydrodynamically efficient body is not built for one explosive strike. It is built for endurance, for holding a course across open ocean at almost no metabolic cost, for following a whale pod for a day and a half without meaningfully spending anything, for crossing entire ocean basins on the energy a stockier animal would burn in an afternoon. Which makes Megalodon something considerably worse than an ambush predator. It makes it a predator you cannot outlast. A body built to go that big should have been permanent. It lasted 20 million years. Then, around 3.6 million years ago, it stopped. Completely worldwide, with nothing left behind but teeth. And the leading suspect is not a bigger animal. There was no bigger animal. The suspect is a smaller one. The great white. The great white shows up in the fossil record, while Megalodon is still in charge of the ocean. It is a fraction of the size. It is not a competitor in any fight you could stage between them. But it does not need to be, because the two of them wanted the same food, and one of them was much cheaper to run. Megalodon, at 20 meters, needs an enormous, uninterrupted supply of large prey. A great white at 5 meters needs a fraction of that, breeds faster, matures sooner, and can survive stretches of scarcity that would kill the larger animal outright. And when the two of them share a nursery, the shallow coastal water where young sharks of both species grow up, they are not sharing it as equals. They are sharing it as a small, fast animal and a huge, slow-growing juvenile, competing for the same fish. And the small one wins that exchange, more often than it loses. Then the ocean itself turned against the larger animal. The Pliocene was a cooling world. Sea levels dropped. The shallow, warm water shelves that Megalodon depended on for nurseries shrank or drained. And the whales, the food supply, the entire body plan was built around, changed with it, moving toward colder, higher latitude water, and getting faster and more migratory as they went. At the same time, marine megafauna across the board was collapsing. Roughly a third of the large animal genera in the world's oceans disappeared in that window. Megalodon was not singled out. Megalodon was standing in the most exposed position when the floor gave way. And that is where the size stops being an advantage and starts being the bill. Everything that let Megalodon reach 80 feet, the efficiency, the reach, the endurance, the long, slow growth to enormous adult size, is a bet on stability. A bet that the warm shallows stay warm, that the whales stay where they are, that the supply keeps arriving. For 20 million years, it was the best bet in the ocean. It only had to be wrong once. So go back to where this started. 80 feet is real. It is the largest number the fossil record can still support, and it is larger than the version Hollywood was mocked for. But the animal that number belongs to is not the animal you have been shown your entire life. The great white blown up to monster scale. The thick body, the blunt weight of it, the thing built to look like a threat. That animal never swam anywhere. It is a reconstruction error, repeated for 100 years, because the only ruler anyone had was the wrong shark. The real one was longer, narrower, cadder, built with the same slender geometry as every other giant this planet has ever produced in water, because that geometry is the only way through. And the last thing worth sitting with is this. That shape is exactly why it reached 80 feet. It is also exactly why it could not stop being 80 feet when the ocean changed. Because you do not build an animal that size on a small margin. And Megalodon had spent 20 million years spending every one of them. The most efficient predatory body the ocean has ever made was efficient right up to the moment. Efficiency was not the thing that mattered. Then it was just very large and very hungry in a sea that had stopped cooperating. 15 million years ago, in warm water that covered half the planet, a whale was swimming alone, and it never saw the shape below it turn. We're still finding the teeth. Beaches, riverbeds, quarry walls, dredge spoil off the Atlantic coast. Hundreds of them every year, from an animal nobody has ever seen intact, and nobody ever will. Every one of them is a single tooth from a single mouth, shed on an ordinary day, in an ocean that had no idea it was temporary. If you want to know what came before Megalodon, the armored predator that ruled the same seas 300 million years earlier, and lost for entirely different reasons, that video is on the channel now. Subscribe to Primeval Blue. We go down there every week.